Hey everybody, thanks for joining me in this video today. So we've been solving systems of equations and up to this point we have been dealing with lines, right? So we have two equations, we have two lines, and we're trying to find their intersection when we solve the system. In three variables we are looking at two planes, of course, but very linear still feel even though in three dimensions. We're going to go back to two dimensions today. And we're going to start dealing with some equations that aren't lines. So take a look here at number one. Okay, the top one is a line, but we can see the second equation has a squared in it. So that would not be linear. Okay, we're going to solve this problem, then we're going to come back and kind of ask ourselves a little bit more about what's happening with that second equation. Our strategies for solving this are going to remain the same: substitution and elimination. So I would be thinking here that in this first one, I could still use elimination. Let me multiply this top equation by negative 1. When I do that, I get negative x plus y equals positive 1. Let's slide the other equation in there. Okay, right underneath, x squared minus y equals negative 1. Multiplying by negative 1 gave me y's that are opposites. So adding them together, I see the y's are gone. I see this is 0. But notice, are negative x and x squared like terms? Can I combine those together? And the answer is no, I can't. So I'm just going to have to write this as x squared minus x. So negative x plus x squared is x squared minus x. Y plus negative y, y's are eliminated, equals 0. And what type of equation did we get here? We got a quadratic. X squared minus x equals 0. I can solve that by factoring out an x. And I end up with two solutions. I get x equals 0 or x equals 1. Now we know from solving we still need to find the y values. So let's take x equals 0. Let's plug it back in and let's get the y value. If x equals 0, 0 minus y equals negative 1, y is 1. If x is 1, 1 minus y equals negative 1, y would equal 2. So I end up with 2 points, 0, 1, and 1, 2. So let's go back to what I said at the very beginning. What type of equations do we have here? How is it possible that we have 2 points, okay, for our solution? 2 points of intersection. Well, the top one's a line, but what is that second equation? If we see an x squared there, the y isn't squared, we see a constant. Isn't this just the equation of a parabola? Right? If I solve it for y, x squared minus y equals negative 1. I'd have negative y equals negative x squared minus 1. I get y equals x squared plus 1. We definitely recognize that as a parabola. So when we're solving this system, we're looking for the intersection of a line with a parabola. Okay, let's go ahead and let's graph those two. Alright, so we've got x minus y equals negative 1. There's that line. X squared minus y equals negative 1. That was that y equals x squared plus 1. And we see our 2 points of intersection, our two solutions that we said. 0, 1 and 1, 2. So now thinking about parabolas and lines, okay, what are the possible scenarios that could work itself out as we try to solve a system where one's a line and one's a parabola? We could have two solutions. Okay. Is it possible to only have one solution? So two solutions would look like that, a parabola and a line. Is it possible to only have one solution? Yeah, it would look something like this, right? Okay, that's called a tangent line. So here we had 2 points of intersection. Here we had just one. Is it possible to have No solution. Certainly. Is it possible with a line and a parabola to have infinitely many solutions? No, the answer to that is no, that wouldn't be possible. To be infinitely many solutions, the two graphs would have to be identical. Now, if we had a parabola and another parabola, that would be possible, but not with a parabola and a line. Okay, let's go to our next problem. Okay. Actually, this is the same problem again. I forgot. I wanted to show you that substitution still works. So we did elimination the first time, but how about we do substitution this time? Let's solve the top equation for one of the variables. And let's say I'm going to solve it for x. We get x equals -1 plus y. Well, let's substitute that in for this x. -1 plus y squared minus y equals -1. I'd like this if it said y minus 1 instead of -1 plus y, because that's going to allow me to FOIL this out a lot easier. That's y squared minus 2y plus 1 minus y equals -1. I see that I have y squared. I have, what, minus 3y. Add in the 1. I have plus 2 equals 0. And guess what? That factors, doesn't it? That's x minus 2, or excuse me, y minus 2, y minus 1, which gives us y equals 2 or y equals 1, which are the same two y values that we had when we solved it the first time. Just now we'd have to go back and get the x's. So substitution still works. Now let's look at another one. Is this, again, a line and a parabola? Yes, it is, right? The top one's a line. We have just an x, just a y. The second equation has an x squared, but the y is still to the first power. Looking at this, let's see here. How do I want to solve this system? I'm thinking I want to use elimination. Let's multiply the top one by -1. Okay, to eliminate the y's. Slide that one over. 2x squared minus y is -4. Add them together, I see 2x squared minus 3x. The y's are gone, equals -2. That's 2x squared minus 3x plus 2 equal to 0. And does that factor? 2x, x, 2 and a 1, minus 4 and a plus 1, but that would be a -2. That doesn't factor, does it? So I have to head to my quadratic formula. We can still do that. X equals -b plus or minus the square root of b squared minus 4ac over 2a. So x equals 3 plus or minus the square root of 9 minus 16. That's -7 over 4. Now we see that -7 there, and we realize that these are non-real answers. So that tells me that there would be no solution. There's no place that this line intersects our parabola. There's my line. There's my parabola, and we can see that they would not intersect. Excellent. All right, what do we have here? Second equation's a line. Y equals 3x minus 5. We should recognize that right away. But is this first equation a parabola again? Notice that both the x is squared and the y is squared. Hopefully you recognize this as the equation of a circle. X squared plus y squared equals r squared. Okay? This is the equation of a circle. So let's think about how a line could intersect a circle? What are our possibilities now? Well, is it possible to have just one solution? Yep, something like that. Is it possible to have two solutions? Certainly. How about zero solutions, no solution? Yep. Infinitely many solutions? I don't think so. All right, so let's see, whoops, wrong direction. Let's see where the circle and line intersect. What method would you use on this one? Okay. Yeah, I would certainly use substitution since one is already solved for y. X squared plus 3x minus 5 squared equals 5. Now I'm down to one equation, one variable, and I'm all good to go. Let's see here. Let's FOIL that out. 9x squared, that'd be a minus 15x, so minus 30x plus 25 equals 5. Let's see, 10x squared minus 30x plus 20 equals 0. I'm going to take out a 10. And I'm going to factor. I get x equals 2, or x equals 1. If x is 2, coming back to our equation up here, if x is 2, 3 times 2 minus 1 would be 1. If x is 1, we get negative 2. So my solutions are 2, 1, and 1, negative 2. All right. Let's graph this one in Desmos. X squared plus y squared equals 5. Y equals 3x minus 5. There we are. Two solutions. Our 2 points. Sweet. Okay. I said right away I'd use substitution because this is already solved for y. Would elimination be an option here? Is it possible to get the equations to work out so that when I add them together, either the x's or the y's are eliminated? And that wouldn't be possible here because in this equation, the x is squared, and I don't have an x squared here. And in this equation, the y is squared, but in this one, the y isn't. So I would not have an option for elimination on this particular problem. All right, number 4 on our final example here. We have x squared plus y squared equals 26. Okay, that would be the equation of a circle again with radius the square root of 26. But look at the second equation. 3x squared plus 25y squared equals 100. Now if that 3 wasn't there and that 25 wasn't there, it'd be x squared plus y squared equals 100. That would be the equation of a circle. Okay. But what is this 3 going to do there, and what is that 25 going to do there? Those are going to be horizontal stretches or compressions and vertical stretches or compressions. Okay. That's going to give me the shape of an ellipse. Okay. Now if both numbers were the same, okay, that's a circle. That'd be like this one, 1x squared plus 1y squared equals 26. Or even if it was 2x squared plus 2y squared equals 26, dividing by 2 on both sides would just give me x squared plus y squared equals 13. That's still the equation of a circle. But in this one, the 3 and the 25 are going to transform our graph by stretching horizontally and vertically. So in this one, we have a circle, or we have and we have an ellipse. So let's solve this and let's see what we get for solutions. I would choose not to do substitution on this one because to solve for any of my variables, I'm going to need a square root and it's going to get rather messy. Instead, I will use elimination. I'm thinking I'm going to multiply the top equation by negative 3. Okay, what is that? 78. Negative 78. All right, add them together. X squared's gone. 22y squared equals 22. Dividing by 22, y squared equals 1. Solving for y, I get y equals plus or minus 1. So if y is 1, what do we get for x? Let me substitute 1 in here. X squared plus 1 squared equals 26. 1 squared is 1, subtracting 1. I get x squared equals 25. Solving for x, I get x equals plus or minus 5. So notice there's 2 points here, isn't there? There's 5, 1, and there's negative 5, 1. But remember, I said y could be plus or minus 1. We just did y equals positive 1. Let's do y equals negative 1. X squared plus negative 1 squared equals 26. That's x squared plus 1 equals 26. Subtracting 1, hey, we're going to end up with the same solutions here. We end up with the point 5. What was the y value? Negative 1. And we end up with the point x equals negative 5, y equals negative 1. How many solutions did we end up with here? 4. 4 solutions. Okay? What were the shapes of the graphs on this one again? A circle and ellipse. What must have this looked like? X squared plus y squared equals 26. Three x squared plus 25y squared equals 100. That's an ellipse. We can see that it's stretched out more horizontally. Okay? And look at that. That's kind of a cool picture. Kind of looks like a planet with a ring around it, doesn't it? Okay? We end up with 2 solutions. 5, 1, 5, negative 1, negative 5, 1, and negative 5, negative 1. All 4 of our solutions. Okay? That's pretty cool. Do we have to get 4 solutions when we're solving the system of a circle and an ellipse? Let's see here. Let's draw an ellipse, something like this. Let's draw a circle, something like that. That's kind of what we had. There's 4 solutions. Is it possible for me to have only 3 solutions? How about 2 solutions? How about 1 solution? How about 0 solutions? It certainly is. So lots of possibilities here with a circle and ellipse. Pretty fun stuff. So substitution and elimination are both good methods. Sometimes substitution isn't going to work well because maybe all the variables have powers of 2. So you should be able to just look and determine what's going to be your best route to solve, just like you're used to doing. Think about what the graphs would be, what the possibilities are for the number of solutions that you have. As you work through these, I would encourage you to open up to Desmos and graph them when you're finished to check your answers. Some fun graphs. Thanks for tuning in. We'll see you next time.